Yeah, good morning, students.
Good morning, madam.
Good morning.
Yeah, enjoy your magnetic lesson today.
Thank you.
Thank you.
Thank you.
Okay, I can see from the chat you are wishing us a Teachers' Day. We are enjoying it. So because today is a Teachers' Day, we are going to enjoy the lesson for so much. Mr. Mbaluka, you can take over. I think it's already time. Those who are going to get in, they'll find us wherever we'll be, and we'll continue together. I can see from the waiting room there are some guys who are there.
Yes, yes.
So I wish to admit them.
Yeah, just.
Mr. Mbaluka, take over.
Okay, good. Good morning, students, from wherever you are.
Good
Morning.
morning, sir.
Good morning.
Okay.
Good morning.
Thank you, thank you.
Morning, sir.
I want to believe that you really enjoyed your weekend. It was magnetic, and welcome back. We missed you. Of course, I missed you since Wednesday. We have not met.
Same.
So let us join together as we swim through the ocean of chemistry. And of course, we are looking at from the feedback that you gave us the other time about the topic that you want us to deal with. We found it right that the rate was featuring more, so we'll be able to deal with it. The other topics like electrochem was also done in Kangundo, but if you find still you feel that it is there after we are through with this, possibly cut dates, prepare yourself. You're likely going to go back to. So while I'm Koapa, get it very seriously. This is physical chemistry. These are topics that we expect like paper 2 question there. We also expect a practical question from that particular end. So it's a very important topic. So let's move on. And the topic that you have seen it from the screen is rate, reaction rate. So my computer is hanging kidogo, but it'll pick too. Yeah, so the topic of interest today is reaction rate and reversible reactions. We expect to look at to be able to define the rate of reaction, and we also expect to be able to talk about the effects of concentration and temperature on the rate of reaction. I'd like you to have a glass, because mko nyumbani, kwa glass moja and weka maji moto. A particular point I'd like us to look at that. Kama uko nyumbani, you need a glass full of hot water and cold water, but sometimes, and tea bags. Kama mko nazo tea bags, just make sure that you have them. That we can utilize them to show something there. So the specific objectives, by the end of the lesson, you should be able to define what is the rate of reaction. You should also be able to draw an experimental setup that can be used to measure the rate of reaction. You should also be able to explain the effects of concentration and temperature on the rate of reaction and state the factors that are affecting the rate of reaction. These are very important topics. Unfortunately, the way it is captured in most of the publication, it is wrong. So be very careful, listen to the nitty-gritty details of what is expected of you when it comes to the examination setup. So what is the rate of reaction? This is the measure of how much of reactants are consumed or how much of the product are formed by unit time. The measure, you know, many books will define rate in terms of the speed with which a reaction proceeds. That's a very vague and unscientific definition. So the most fundamental definition of rate is the measure of how much of the reactants are consumed. Remember, in a chemical reaction, we have reactants reacting they converted to products. So you can measure the rate of reaction with the reference to the consumption of the reactant or the production of the reactant. So we are talking about this is the measure of how much the reactants are consumed or how much products are formed by unit time. I can just give you an example of reaction between calcium carbonate and dilute hydrochloric acid. What do you get when you react calcium carbonate and dilute hydrochloric acid? Students,
Calcium chloride,
Uh-huh.
calcium chloride,
Uh-huh.
carbon dioxide plus water.
Good. So there are two ways you can measure the rate of that reaction. How? You can measure the mass remaining, the mass of calcium carbonate. Unaweza chukua a weighing balance, then uanze kupima the first in the initial stages before at the start of reaction, the mass of calcium carbonate was 5 grams. After the first 5 seconds, it may reduce to 4.8. After 10 seconds, it may go to 4.5 grams. So the mass of calcium carbonate will be decreasing. That is one of the things you can talk about, the decrease in mass of calcium carbonate. Or what else can you use to measure the rate of reaction there? You can also, because we also produce carbon dioxide, as one of you have said, we can also be measuring the volume of carbon dioxide produced per unit time. So that's it. So there are two ways. That's what we are saying. Measure how much of the reactant are consumed or how much of the products are performed per unit time. So, and the rate of reaction is going to change in amount of product or reactants divided by the time taken. Very important. So the apparatus used to determine the rate of reaction. The apparatus used to determine. I just wanted to deal with the that because there are some abnormal people who are just writing on the screen. That is not very good. So now, so whatever we are saying is the apparatus that are used to measure the rate of reaction are the graduated syringe. That is to measure the volume of gas produced. We also have stopwatch to measure time. We also require a conical flask, or what you call the reaction vessel, and that is where the reaction takes place. We need an electronic beam balance to measure the change in mass of the product. Yes?
Excuse me.
Yeah.
Please go back to the previous slide I screenshot.
Have you done that?
Yes, sir. Thank you.
Good. So the apparatus that you need there is
thank
the
you.
graduated beaker. You need a graduated beaker. And this is now, it must be graduated. Graduated means it is calibrated. It has a measurement, unaweza ona 10 mils vitu kama hizo. Graduated syringe or a graduated even gas jar. We need a stopwatch. We need a conical flask or rather the reaction vessel or electronic beam balance. So let's look at a setup because this one has been tested more than 7 times. To draw a setup that you can use to determine the rate of reaction between maybe calcium carbonate and dilute HCl. There are two ways there. One, you can be told to explain or rather to draw an experimental setup that can be used to measure the volume of the gas produced. You see, this one is to measure the volume. So because here you are measuring the volume of the gas, you need a syringe. So here we don't need a beam balance. We are only using a syringe. This syringe, as you can see from my end, it is graduated. Graduated ndio hii, calibrated. Iko na measurement. Unaweza pima like now from here, it means the student can measure 5 seconds. You know, it doesn't have to be very magnetic. Hata ukichora tu hivi.
Teacher,
Yes?
excuse me.
You are saying what?
Go back to previous.
Huh?
Please go back, review the previous line.
Na uharakishe tusi ninio sana. You have done it? Sawa, ume screenshot, eh? The student who was saying, have you done the screenshotting, eh?
No, more than we
Okay. Now, whatever I'm saying is this is a syringe. Assume this is a syringe. This being a syringe, whatever we are talking about, the graduation, bora to the examiner can see something like this. It doesn't have to be here to answer kuchukua art and craft. So provided we are able to see, if this is a syringe, we are able to see this line there. It means your syringe is graduated. Come on, if you are collecting using a gas jar or a measuring cylinder, it must have it must be graduated. That's what we mean by graduated.
Mr. Mbaluka,
Yes?
there is a student raising up his hand called James Mulay.
Anasema nini?
Amepotea, wachana na yeye.
Okay. So,
Just continue, Mr. Mbaluka.
James is also making noise.
Then you just unmute. Okay, let me see. I can mute all of them.
Let me.
I've muted all of them, so it's okay. Okay, good. I think now you're able to hear me. Now,
Yes.
this is the setup.
Yes.
How beautiful it is. You don't have to draw those things like that in exam. Ile kitu tunataka tu, let your syringe be graduated the way I'm showing here. Number 2, this is the stopwatch. The stopwatch hata ukitorea aje, provided we are able to see. When if you tell us this is our stopwatch, and we are able to see 0.00, that's okay. So then you just say this is a stopwatch, whatever. The examiner will just be looking for anything that looks, don't have to come up with a very beautiful stopwatch like mine, or very beautiful things like this. So just remember what I've said, that we're just looking for this label there. This shows this thing is graduated. Unaweza onyesha, you can read. That's it. Just the way those people, even those who sell paraffin, wanachukua chupa ya ile ya soda na wanaweka tapes hapo. That means it's graduated. That's what we mean by graduation. It has some reading that you can see. So the examiner will be looking for reaction vessel, atakupea tick, atangalia the syringe, it must be graduated, there must be a stopwatch. Those are like marking points. Remember, in the setup, we also have the concept of the reactant. We also give it a lot of noise coming from, I don't know. Anyway, I've muted all of them. So I want to believe you're able to hear me. Now, so that is the setup. But this setup is a setup to prepare, to collect, to measure the rate of reaction, and also whereby we are talking about the volume of the product, to measure how much of the gas is produced per unit time. That's the setup for that. Let's look at another one that is dealing with the product. This one is dealing with the product. It is measuring how much of the product is formed per unit time. We want to know a setup that demonstrates how much of the reactant is formed per unit time. That is it. So this one now, we are talking about the reaction between calcium carbonate and hydrochloric acid. Our point of reference here is to measure the mass of calcium carbonyl remaining per unit time. But remember, for this one now, we are measuring the mass of the solid remaining. That is the reactant consumed. The stopwatch has to be there. The reaction vessel has to be there. But here we don't have, we are not, our interest is to measure the mass of the solid consumed, rather remaining. Therefore, we don't need a syringe here. We don't need a syringe here. So, like in the previous, our interest was to measure how much of the gas is produced per unit time. So in this point, we are not interested with the solid. So we don't need the weighing balance. But for the next, that's it. Because remember, this thing can be set in a different way. That wherever you're talking about that, you can be asked about this. You can be asked about draw an experimental setup that can be used to measure the quantity, the amount of the calcium carbonate remaining at time per unit time. So in that kind of a scenario, you need this. And if I may ask, why are we not using a tight cork here and we are using a cotton wool plug? Why? Why are we using a cotton wool plug? Student? Huh? Because of what?
Because rubber is highly reactive.
Rubber is highly reactive, good trial, but not very magnetically correct.
Allow the gas
Yes?
allow the gas produced to
Yes, we are producing carbon dioxide here. We are having carbon dioxide here. This carbon dioxide is being produced. If there is no escape route, this will lead to a violent, and I'm talking about a violent explosion. You may even end up losing your nose in the process. Utaona hiyo chupa itaanza kutembea peke yake. Utasikia imegonga mabati imepita na wewe. So that kind of a scenario, that is simply to allow, to prevent the buildup of carbon dioxide there. So it is to allow it to escape. You cannot be preparing a gas being produced there and then it is tightly corked. And that's why even in preparation of gases, the gas jar should always be covered with a cardboard. So that in a case it is filled up with the gas, then it is very easy for it to escape. That's it. Then finally, we talk about the factors affecting the rate of reaction. The rate of a reaction can be altered or rather can be affected by several physical factors, and the effect of these factors can be explained in terms of collision theory. For a reaction to take place, the particles taking part in that particular reaction have to collide with sufficient enough energy to bring about a chemical change. You will never explain the rate of reaction without invoking the collision theory. So mahali popote utakuwa una explain the rate of reaction. Make sure that in your explanation, you must bring up the concept of the collision theory. Reaction will never take place unless the particles are able to collide. So that is it. So the effect of these factors affecting the rate of reaction, it has to be explained using the collision theory. Let's look at, it is assumed that for a reaction to occur, the particles of the reactants have to collide with sufficient kinetic energy to bring about a chemical change. The minimum amount of energy required for a reaction to take place is called the activation energy.
Hatuelewi.
Eh? Nini uelewi?
Sha go back to the
Okay.
Too fast.
Sha.
Yeah.
Sha.
Yes. I repeat,
Unaongea haraka.
nimesema hivi, for a reaction to take place, we have the reactants. It is the particles that are reacting. Tuko pamoja hapo, Are we together?
Yes.
Just that those particles, they have to collide. And that is what you're calling about what? Collision theory. Like when you're talking about magnesium react with HCl, for that magnesium to react with hydrochloric acid, lazima utumbukize hiyo magnesium ribbon to the HCl, meaning that the hydrochloric acid and the magnesium particles have to collide. Are we together? Umeelewa hapo?
Yes.
And the collision, the particles, as they collide, they must have enough energy to bring about a chemical change. Not all collision result to a chemical reaction. Particles neither, like for example, unaweza tumbukiza tu magnesium ribbon na utoe tu na upate hakuna kitu imereact. You can just put it there. Unaweza chukua iron nail utumbukiza kwa acid na utoe kwetu sawa. Kwa ija react, but the collision, they must have enough activation energy to bring about a chemical change. And I think that is now understood. So whatever you're saying, it is that. Yes.
Kuna student ameinua mkono.
Aulize.
Kuna student ameinua mkono kama kuna swali.
Yeah.
Ubaya ana jina anaitwa Neon Ray.
So aulize.
Neon Ray,
Jeff.
I think amepotea. Yes.
That student cannot talk because his audio is not active. The student cannot speak.
Mtu amwandikie message aoni, I think he doesn't know to ama kuna shida ya audio. Lazima connect audio. So now we are talking about that for this particle.
Excuse
Baluka.
me.
Yes.
Baluka.
Yes.
Can you ignore that student? Tumeshinda tukisema rename himself na atakangi.
Yes, exactly. So we are saying that student, that for a reaction to occur, the particles of the reactant have to collide, and as they collide, they must have what you call sufficient activation energy to bring about a chemical change. And that is why when even sometimes we are carrying out a particular reaction, sometimes we are required to heat the reactant. Like when you want to form copper sulfate, you warm the sulfuric acid. This is to enhance the provision of enough activation energy to bring about a chemical change. That activation energy, that minimum energy that is required to bring about a change is called activation energy. Let me ask you one thing. While you are at home, and I know some of you are using gas cookers, you know, for a gas cooker, the gas that is stored in the gas cooker, in that gas cylinder, it only reacts with oxygen in the air. So when you open the gas cooker, does it light? It doesn't. So for it to light, to produce the flame, what do you need to do? You need to ignite it using a what? A matchstick. So that matchstick is the one that now provides the activation energy to bring about the combustion. So that now the gas from the gas cylinder, when it mixes with atmospheric air, it is able to burn and produce a flame. But that combustion cannot take place unless you you ignite it with the matchstick. So the matchstick is the one that provides the activation energy. So in a nutshell, what I'm saying is that in any reaction, there are particles. Those particles, they have to collide. For a reaction to take place, the particles have to collide. And that collision should have enough energy to bring about a chemical change. So all the factors that affect the rate of reaction will be explained in terms of collision theory. Umeelewa sasa, eh?
Yes.
Good.
Yes.
Now,
Yes.
can you list for me the factors that affect the rate of reaction? Just list for me.
Temperature, temperature, concentration, pressure,
Amount or concentration.
surface area.
Good, good, good. Very good. Very magnetic student. Now look at them. Koala alikuwa amesahau. Let me remind you. Let me remind you. Concentration, temperature, catalyst, pressure, particle size, and light. Now, those are the particles. You can screenshot as we now go to deep details of how to explain that kind of a scenario. We are good to go?
Yes.
Yes.
No.
Yes.
Yes.
That's 1 minute.
Yeah.
Okay, good.
Yes.
Concentration. How does concentration affect the rate of reaction? Students, somebody to explain that?
Increase in concentration
Yeah.
increases the rate of reaction, and decrease in concentration decreases the rate of reaction.
Very good. Is that correct?
Yes.
Yes.
No.
Somebody has said no. Can you explain? Kuna watu wameinua mkono hapo. Can they say something?
The Jambi.
Increase in concentration increases the reacting particles, increasing the chances of successful collision.
Good.
While the
Yes, the way Jambia said, listen very carefully. So the issue of just saying increase in concentration, increase the rate of reaction, that one is very good answer, which has no mark. It has no scientific meaning. You have not even invoked the collision theory. So this is how you bring it. Of course, concentration is a measure of amount of substance per unit volume. So what do you explain? This is now the marking point from here. Increase in concentration increases the number of reacting particles. Increase in concentration increases the number of reacting particles in the system, leading to higher number of successful collisions and hence faster rate of reaction. Look at that point, is increase in concentration will increase the number of reacting particles in the system. Not just, don't argue like somebody who has never gone in a class. Don't just say increase in concentration, increase the rate of reaction. I'm saying increase in concentration will increase the number of reacting particles. So there are more reacting particles. The higher the number of reacting particles, the higher the number of effective, or rather successful collisions, and therefore the faster the rate of reaction. On the same scenario, the lower concentration means there are fewer number of particles in the system. And this will lead to fewer effective collisions. So that's how you explain it. Point number 2 that you need to talk about. Concentration is only for aqueous solutions. Concentration is only for aqueous solutions. You cannot talk about concentration of calcium carbonate. So that's why we are using the other word, which is what? Amount. Never talk about, example will give you this trick. Utaulizwa, how will the reaction between calcium carbonate and dilute hydrochloric acid increase? Or rather, how does concentration affect the rate of reaction between calcium carbonate and hydrochloric acid? And somebody will be talking about now that the concentration of calcium carbonate. Once you talk about concentration of a solid, that negates the whole explanation. So remember, you can, for solid, use amount. Remember, concentration is normally for aqueous solution. That you can define is molarity. That mostly, that is what you talk about for aqueous solutions. Amount can be used for any. For solid, for gas, even for aqueous solution, we can talk about amount. So just make sure that you are able to get that point very well. So that's it. Increase in concentration increases the number of reacting particles in the system, leading to more effective or rather successful collision. Not just the collision, talk about the orientation of the collision is more effective, more successful, more fruitful collisions. So an effective or rather successful collision is that collision that leads to formation or rather to a chemical reaction. I think now you're okay about that. The matching point, the matching point, or rather the key word in that explanation. Is it okay, students?
Yes.
Umeelewa
Yes.
sasa, eh? Very magnetic.
Yes.
Now, good.
Yeah.
I want to give
Mr.
you.
Baluka.
Yes.
Mr. Baluka.
Yes.
There is a student who was raising up his hand called Gordon Onyang.
I will leave there.
I'm asking. Hello?
Yes, we are getting
Yes.
Hello?
We are getting you.
As where we have how the concentration affect the rate of reaction.
Yeah.
Can it be successful without the energy included? Can it?
Which energy? So, yes.
Kinetic energy.
No, you
Or
don't talk about
activation energy. I mean activation energy.
You're not talking about activation energy. There's somewhere whereby you're going to talk about that. So for in terms of concentration, you only talk about the number of particles in the system. I want to give you a clip. You can listen to it. So, Nyango, mambo ya kinetic na energy tutaiongea mahali pengine. Just relax, eh? Just relax. So I know you have sublimed. You just come back to the room temperature, settle down. Then as we move forward, we'll be able to navigate through another factor that is going to explain the concept of the activation energy. Sawa. Okay, very magnetic. Okay, good. Can I share a clip?
Yes.
Mnaisikia? Mmesikia sound mali?
Yes.
So we continue.
Hi, welcome back to freesciencelessons.co.uk. By the end of this video, you should be able to describe in terms of particles how the rate of a chemical reaction is affected by the concentration of reactants. You should then be able to describe how this can be investigated by an experiment. In the last video, we saw that particles must collide in order to react. In chemical reactions, the reactant molecules change into the product molecules. We can follow the reaction by measuring the amount of product made over a given time. The gradient or steepness of the line tells us the rate of the reaction. The steeper the line, the faster the reaction. Initially, the reaction is fast, because there's a high frequency of collisions between the
Sorry, kuna mtu ana interfere. There's somebody who is interfering with our.
Hey.
molecules. The reaction then slows down because some of the reactant molecules have converted to product. So there's now a lower frequency of collisions between the remaining reactant molecules. Finally, the reaction stops when all of the reactant is converted to product. In chemical reactions, the reactant molecules change into the product molecules. We can follow the reaction by measuring the amount of product made over a given time. The gradient or steepness of the line tells us the rate of the reaction. The steeper the line, the faster the reaction. Initially, the reaction is fast because there's a high frequency.
Okay, I want to go explain. I want to believe that you are able to get you are listening and you are able to get some of those things. But I want to explain some of the things that this Zungu is talking about here. And number one is ikianza, it is very stiff. Unaona vile iko?
Yeah.
Here the curve is stiff. The stiffness of the curve indicates how fast a reaction is starting. So assume here we are reacting calcium carbonate and hydrochloric acid. Initially the reaction is very fast. That's why the curve is very stiff. You can see faster reaction, high frequency of collision, because when the reaction is starting, there are more reactants. So as the reaction proceeds, the reactant particles are being converted to product. So that's why you see, ikiendelea hapa inaanza kuwa gentle. Na inaenda mpaka finally inakuwa nini? Ina flatten. So you can see the curve is very gentle here. Means the reaction inaenda kama tortoise. Pole pole, pole pole, pole pole. So let's continue.
Frequency of collisions between the reactant molecules. The reaction then slows down because some of the reactant molecules have converted.
These questions are very common in exam. So as the reaction proceeds, there is a slower reaction because some of the reactant particles have been converted to product. So the concept of concentration is also being captured here, that as the reaction proceeds, some of the particles are being converted to product. Therefore, the number of particles are decreasing and the rate of reaction is slowing down.
To product. So there's now a lower frequency of collisions between the remaining reactant molecules. Finally, the reaction stops when all of the reactant has converted to product. So in this video, we're looking at the effect of concentration on the rate of a reaction. Remember that we can increase the rate of a chemical reaction if we increase the frequency of collisions, and we can do this by increasing the concentration of the reactants. So this shows a reaction with a low concentration of reactants. You can see that there's only a small number of particles. That means there's a low frequency of collisions, therefore this is a slow reaction. This shows a higher
So students, are you looking at the real explanation there? In the first part, the particles are very few. In the other side, there are more reacting particles. So you can only explain the rate of reaction with the reference to the number of particles in the system.
Concentration of reactants. You can see that now we have more reactant molecules. That means there's a higher frequency of collisions and therefore a faster reaction. If we plot the amount of product for these reactions, we can see that the lines look different. Firstly,
okay, listen. GA story, this curve is wrong. So I don't want you to be guided by this. This one is wrong. So we'll now deal with the correct one. So this one is Katanga. Cannot be accepted. So we continue now with the next one, which makes sense. So now, listen. There's a lot of noise. Just want to. Good. I want to believe you are getting me because there was one of the synthetic allotrope Buckminster fullerene which was making noise. So we had to unmute to mute him. Now, listen carefully. This is the curve showing how reaction proceeds in a normal setup. So this curve, just listen very carefully. So this is the curve. Inamaanisha this is the time and this is the mass, total mass or total volume product. So you can see when it is starting, it is very, very stiff, as you can be able to see. That's point A. The curve at point A, the curve is very stiff. It is very steepest. The steepest, that's the point. Why? At this point, it has the highest number of reacting particles. The reaction is just starting. So as we proceed here at B, this one is less steeper. It is less steeper. So this one now, some of the particles have been converted to reactants, and therefore there are fewer particles. So as the reaction proceeds, this one becomes a little bit less steep, or rather it becomes gentle. You can talk about gentle. You can say it's a little bit gentle. But now here, at this point, the curve flattens. The curve flattens because all the reactants have been converted to products. So in that kind of a scenario, we are talking about, you are going to be finding this kind of question. That initially, when the reaction is starting, the reaction is very fast. And that's when you look at the curve, they are very steep, they are steepest. The curve is steepest here. It becomes gentle, rather, is less steeper because the number of particles, reactive particles are decreasing. So there is slower rate of reaction. Number two, this simply explaining the shape of the curve. I don't know why we have so many students who are not very normal. You unmute yourself, you start making noise. That's not a normal student.
Yeah, you're muted. We can't hear you.
Show me to mute.
Sure,
Sorry.
you're muted.
Okay, good. Ni mtu amenimute tu. But ni sawa. Mnanisikia sasa eh? I'm saying there are two ways eh? Mambo concentration, you can be explain it in terms of the shape of the curve. Yenyewe tu. So looking at this curve, initially at point A, this is when the reaction is starting. More of the reactant particles are present, so the reaction is very fast. As the reaction proceeds, some of the reactant particles are converted to products. So there is decrease in the number of the reacting particles. And therefore, the rate continues to become gentle. The curve becomes gentle. And finally, the curve flattens after all the reactants have been converted to products, or rather after the reaction is complete. That is one of the scenarios that you're going to be finding, or rather you'll be asked. I'll come to that later. Number two, you can be told, like this one was, you can be told, like this is 1 molar HCl. Hii curve ya hapa. Na uambiwe, it was repeated using 2 molar HCl. So if the concentration is higher, for a curve that for a higher concentration, the curve will always be on the left. Itakuwa left because when you draw something, like if I have to draw, let me just show you. If I draw a curve here like this, nikichora ingine hapo. Na ingine acha nichore na different color. Like green. Ingine nichore hapo. Tell me which curve, but green, red, and black, which one is stiffer? Which one is very stiff?
Black.
Black. Which one is
Black.
which one is the most gentle?
Black.
Green.
In that case, ujue, for a slower rate of reaction, the curve yake itakuwa tu on the right. But for a faster, will always be on the left. That's it, just like that. And number 2, this curve, unless otherwise I'm going to explain later, should always flatten on the same point. Si ati kama hiyo ya mzungu uliona ingine inachorwa hivi inapita hivi. That is katanga. That's not correct. Because acha nikuulize. Sorry. Sasa nime delete yote but ni sawa tu. I think we had already coded that. Let me just ask you one thing. Unapika githeri na gas cooker, unapika na jiko, ama unapika na electric heater. Which one is the fastest?
Electric heater.
Electric
heater.
Electric.
Yeah, you know what tunasemanga science is
Electric heater.
Wewe sikiza vizuri. Nawaambianga science is more empirical and pragmatic than theoretical. Rather, science haya sasa tena kuna animal wengine tena
Mbili kusimletea ujinga mwende huko hata mnanipigia kelele.
I think I'm not muted because now there was again another watu wa kutusumbua tu hapa. Now listen. Tunasemanga science is more pragmatic than dogmatic.
Yes,
when you're saying electric heater is faster, hiyo ni ugongo yako kabisa. That is now invoking the dogmatic theory.
You're breaking somehow. So kindly repeat this graphical product. Yeah.
Which graph? Tunasema, of course, I'm just repeating this kind of a scenario because I may not be able to repeat everything because if you are broken, this thing we are recording, tutaweka mahali yenye mnaweza sikiza. So you are following my graph, isn't it?
Yes.
Yes. We can't repeat, but I'm going to put it somewhere that whereby you can read, you can listen. Now, let me tell you now. I'm saying science is more pragmatic than dogmatic. When you're saying electric heater is not, the fastest cooker is the gas cooker, not the electric heater.
Is it?
Hello. That's the correct chemistry. Ukichukua gas cooker uwakisha tu na kibiriti inawaka immediately na inaanza kufanya kazi. What about electric heater? Electric heater itaanza lazima hiyo coil ianze kuwa hot ndio ianze kuwarm hiyo kitu. It takes a lot of time. In fact, ukiweka chai uende kwa bathroom uende kuosha mawenge nyama, before you come back you find the tea imeshamwagika kila kitu. So in that kind of a scenario, that's not the point. I'm not explaining the concept of it, but I'm just telling you. Ukichukua kilo 2 za githeri upige na hiyo electric heater, vingine upige na kuni, yenye umepiga na electric heater gas cooker itakuwa kilo 10.
No.
So the only thing, the product is the same. The only thing that varies in ni rate, ni time taken. Like look at, kuna hiyo ilikuwa kama hii, where it flattens inamaanisha reaction is complete. Like hii imeflatten hapa, inamaanisha hiyo ndio time 1, faster rate of reaction. Then time 2, slower rate of reaction. Na ndio maana nakwambia ukichora, be very careful. Unajua wengine mnachoranga tu vitu hivi. Mnachora. Finally unapata ina level at the same time. So it should be kama hii ni faster, iko hivi. Ime flatten hapa, hii ime flatten hapa, hii ingine ni slower rate of reaction, imekuja kuflattenia huku. So we should be able to look at that. So don't be like that one that we show from the Muzungu. And it's a common mistake. Watoto wakiambiwa faster rate na slower wanachoranga hivi. Mtu anachora hivi na ingine anachora hivi. 2 molar and 1 molar. This will be penalized ruthlessly. Although there are sometimes later, as I said, come back to the room temperature, assume the room temperature, the standard room temperature and pressure. Then from there, after later, we'll be able to do that from there. Temperature. How does temperature affect the rate of reaction? Students, how does temperature affect the rate of reaction? How does temperature affect the rate of reaction?
Temperature increases the kinetic energy in the particles, hence increasing the number of successful collisions.
It increases the what?
The kinetic energy in the particles of the reactant, hence increasing the number of successful collisions.
Good. Kinetic energy. Mwingine nimeona wengine wameinua nini? Madam Ruth, are you there? Can you check those who have written their hand? Those who have raised their hand.
Yes, I will.
Kuna mtu anasema kitu? Okay, I think I can just give you the point. Na hapo nataka mfanye hivi. Ni vile hatuna time, ningefanya but naona itanitekea a lot of time. But I just want you to take this. You can do this one practically at home. You don't need anything. Ukiwa pale nyumbani, hapa tuko na students. Tuko na shida watoto wenye kusumbua tu kabisa. Now, listen students. Increase in temperature. Nimesema hii kitu nataka muifanye practically hapo nyumbani. Chukua a glass of water. Uweke moja maji moto, ingine weka maji baridi. Chukua tea bag. Uweke both at the same time. Give them 1 minute, 30 seconds, 42 give it 1 minute, maybe 42 seconds and 33 microseconds to settle down. Then you look at it. Utaona. By the end of maybe 1 minute, 30 seconds, utapata, you'll tell us which one will look more yellow, which one looks more brown or things like that. Just look at the diffusion. With that explains the effect of temperature. You can just do it. It's only that I don't have a lot of time to kwenda kwa sufuria. Yes. Yes. Madam Ruth. Students, mnanipata kweli?
We can hear you, Mr. Mbaluka.
Yes, we can get you.
Yes, Mwalimu.
Good. So we are saying this is a marking point. So nimesema hiyo tujaribu kufanya at home. Chukua glass, moja kuna maji moto, ingine baridi. Weka tea bag and observe the color changes. So this is the marking point for purposes of exam. Increase in temperature increases the kinetic energy of the reacting particles, leading to a faster movement of the particles, and this leads to more successful collisions. So we have the marking point here. Increase in temperature increases the kinetic energy of the reacting particles, leading to a faster movement of the particles, and this leads to more effective collision. You have been at home. Have you ever, I can just explain that concept, that you have been at home, kwa wale mnalea ng'ombe, kuna wakati tunasemanga the cow is on heat. See heat here, temperature. So when the cow is on heat, it is going to make a particular sound. Inasema, I am ready to be taken to the next world. So when it makes that funny sound, the bull, which is somewhere, will also hear the same. What happened is that now the bull will start running towards you. I'm going to ski.
Tunakusikia.
We
can
hear
you, sir.
Okay, now I'm saying when the cow is on heat, it starts making funny sounds, isn't it?
Yes.
Those funny sounds are received by a bull somewhere. The bull will know there is a queen somewhere who needs some special treatment. This communication will make the bull and the cow to start. The bull will also make a particular kind of a noise. So it's like they acquire some special powers to start, and they start running towards each other. So the particles start coming close to one another. And when the bull and the cow meet, where the Malewazitapatana in the middle of that ground, they are able to combine together, and they form a white precipitate. The reaction takes place, and they form a
Najoma.
So now, you need, a certified working chemical. That's the concept. First of all, there is the particles gain kinetic energy. They move faster. If they move faster, they are able to come together. And this leads to more effective collision. So whatever I'm saying, usianze kusikia hapo upate ile kitu umepata ni ya ng'ombe peke yake. You are not without getting the scientific explanation, the correlation. That the particles, the kinetic energy, that will be the most important point. The kinetic energy of the particles increases. And they move faster. And this leads to more effective collision. Mimi nasikia watu wakisema hawasikii. Amunipata?
Tunakupata jo. Tunakupata mwalimu.
Now we can hear you.
Okay, good. So have you got that point? Have you got that? Kama unisikii na wale wengine wanasikia, inamaanisha wewe ndio uko na shida kwa side ya network. Na vile nimesema, we are recording this thing. I'm going to put it somewhere in the YouTube. Whatever I'm saying is this. Sasa unajua watu wengine tuka allotropes who are not I don't know. Now I'm saying this that when you
wameinua mikono.
Yes.
Kuna students wameinua mikono, tafadhali waulize maswali.
They unmute themselves and they ask a question.
Those who have raised hands.
Lini Wanjiru ameshinda
Mr. Baluka, endelea.
Yeah?
Anacheza, endelea.
Okay, I'm saying.
He's joking, just go on.
The marking point here are as follows. When explaining effect of temperature, you said it, increase in temperature, increase the kinetic energy of the reactive particles, leading to a faster rate of reaction. Faster movement, increase the kinetic energy, increase the temperature, increase the kinetic energy of the reacting particles. They move faster, and this leads to more effective collision. Sijui kama kuna mtu amefanya hiyo mambo experiment nimesema mfanye. Kuna mtu amefanya?
Ndio.
Yeah.
Imekuja aje?
Nimekuwa na maji moto ndio na haraka.
Imekuwa na maji moto ndio imekuwa?
Imekuwa more brown, more yellow.
You have done it, eh?
Yeah.
I wish you tungeona mtu amefanya. But
unfortunately.
Okay, let's listen to this.
Atuweke kwa video.
Unasikia hiyo video eh? Niwekee kidogo.
Yes.
Hi and welcome back to freesciencelessons.co.uk. By the end of this video, you should be able to describe in terms of particles the effect of changing the temperature on the rate of a reaction. We've already looked at several factors which can affect the rate of a reaction. Remember that particles must collide in order to react. The frequency of collisions determines the rate of the reaction, and the word frequency simply means the number of collisions per second. If we have a greater frequency of collisions, then we have a faster reaction. Now, there's one key idea that we have to explore, and this is called the activation energy. It's really important that you learn this definition. Particles have to collide with a minimum energy in order to actually react, and we call this energy the activation energy. So let's take a look at the effect of temperature on the rate of a reaction. This reaction is taking place at a low temperature. You can see that the particles do not have very much kinetic energy and are moving slowly.
You see, from my explanation, the concept of kinetic energy and the movement must be captured. Low temperature, lower kinetic energy, they move slowly.
This means that collisions are less frequent and have lower energy. In this case, the reaction will be slow. This reaction is carried out at a higher temperature. The particles now have more kinetic energy and move more rapidly. It means that collisions are more frequent and have more energy. So this reaction will be faster. Another key feature of this reaction is that the particles that collide are more likely to have the activation energy and collide successfully. Okay, so to summarize, if we increase the temperature, we increase the kinetic energy.
Just screenshot that point. Increase in temperature, increase the kinetic energy of the particles. They move more rapidly and more frequently. Particles are more likely to collide with the activation energy. So the only concept there is now increase the temperature, increasing the kinetic energy of the reacting particles, leading to more effective collision. Just like that. So graphical illustration of effect of temperature on the rate of reaction. This simply repeats. Lower temperature, the reaction is slower. High temperature, the reaction is faster. Period. So, can we continue?
Yes.
Yes.
With this one, there is nothing to explain there. With that one, just like for the concentration. Kama temperature is more 40 degrees unaweka on the left, lower temperature on the right. Catalyst. A catalyst lower the activation. And yes?
I have a question now. Is there a degree that reaches that the kinetic energy cannot be more when let's say is there a degree that the temperature reaches and the kinetic energy remains constant from that degree upwards?
Yeah, there is you know that we have moderate temperature. You know, like now you may even you cannot use the temperatures of hell because you don't want to melt a ghost. You just want to carry out a chemical reaction. So whatever you need to do is like you see. Now take for instance a liquid like hydrochloric acid. Take for instance. If you use a very high temperature of hydrochloric acid, finally you are not going to have hydrochloric acid. It will be converted to hydrochloric acid vapor. When you heat solid, the temperature when it's so high, the solid will melt, and finally after melting, it's going to evaporate. So it depends on previous temperatures, but it depends on the reactants, but we have a specific temperature. Of course, you cannot use a temperature of 1000 in a normal reaction. All the reaction that you're going to carry out in our normal setup now will be a temperature up to around 80. Remember, even in the school level, that we use the alcohol and the mercury thermometer that goes up to 110. So you're not going to be using a thermometer that goes to 200. Number two, I can tell you for free, even for practical experiment, you're not going to carry out an experiment with the temperatures above 80. 85 mostly there. Because the temperature, you cannot be given a temperature that cannot easily be measured using the alcohol, the thermometer, or the mercury thermometer. So normally, if you use a very high temperature, it's going even to affect even the physical state of the reactants and the products. Naelewana kijana?
Yes, thank you. Thank you, Mwalimu.
Okay. Mr. Baluka?
Yes.
There are these participants from Maweni Secondary. They have been raising up their hand. I don't know what they want. Maybe they can unmute and speak.
Yes.
Maweni, mumekuwa mkiinua mkono, sijui mnatakaje. Okay, there is another one called David Mutiso. Kindly unmute and speak. Mr. Baluka, continue.
Okay, because I'm thinking we are having like 10 minutes, I'll start from there from next week. In our next lesson, we'll start from there, but there is a question that I want them to go and draw the graph. Then we can come to coordinate that. So I just want to, because of time factor, this one needs to be explained further. So now, can you screenshot student that one? You take it as an assignment, you try to draw the graph so that we can just come to discuss from there, and also the effect of temperature. So can you screenshot that? We only have 10 minutes, and I also want to see if there is a 8 minutes fact, be precise.
I'm done.
You have done, eh? You have done the screenshot.
Yeah,
Then
yeah.
the question is there.
Yeah. Yeah.
You have done it?
Yeah.
Yes. So attempt that question. Next time we'll finish up with the catalyst, because the catalyst, it has so many things, because we're also invoking the concept of the activation energy, the energy profile diagram, energy level diagram. So in that kind of a scenario, so I think I can just request any questions. Any questions?
Mr. Baluka.
Yes.
Give us the first question. The
Which
slide
question?
for first 1A.
Ndio hii inafaa kuwa hapa A.
Sawa.
Plotting the graph. So any question? So that's it.
See, just short cha.
Yes.
Cha.
Yes.
The first slide.
Which
just
one?
Screenshot assignment.
Yeah, assignment.
The
assignment cha.
Yo.
Santi.
Okay, I go to the next.
Yes.
So now I'm waiting for a question.
Mwalimu, factors ya effect of reaction ya hizo slides.
Mr. Mbaluka?
Yeah.
Yeah, there's a question here.
Yes.
Explain why the curve is steepest at the start of the reaction.
Okay, good. I said for this one, I think we go to concentration. The curve is steepest at the start of the reaction because when the reaction is starting, there are more of the reactive particles. And as the reaction proceeds, some of the reactants are being converted to products. And therefore, initially, at the initial stage of the reaction, the rate of reaction is faster because there is higher number of reacting particles. So that is the reason why the reaction is faster at the beginning. And as the reaction proceeds, the number of particles decrease. The number of reacting particles decrease because some of the reactants have been converted to products. And it reaches a point whereby the curve flattens. And that is when now all the reactants have been converted to products. And therefore, there is no more reactant to react. Rather, the reaction is complete. Any other one? I want to believe that we'll be able to do the curve. The curve, somebody still talk about the curve. As I said, I hope we have still some 4 minutes. Let me show you. Nimesema the curves, kuna mtu anasema onyeshwe how to do the curves again. Yoni. So you have the So that being the case, is the curve number 1. So if you have to draw a curve for a faster rate of, or rather higher concentration, for higher concentration, it has to be on the left. Then we have another one for a reaction which is low. It is starting on the same point. Then like that. So this one is a slower. The reaction here is slower. Slower rate of reaction. This one is faster. The black one is the fastest. This one is the fastest.
So what about the green one?
Which grid?
Green curve.
Go, Jatu. This one green is the original one. Umepewa hii na ukaambiwa. Now the reaction is now current. Assume like the green one. I think we can just give the, like this one can be 1 molar HCl. 1 molar HCl. That is number 1. 1 molar HCl. Then that is the first one. Then this one becomes 0.5, 0.3 molar HCl. And then this one, the one that we have here, ile black palette, equal to 4 molar H. Sorry.
Dennis Wanjala.
Kuna mtu anauliza sasa hapo. Look here. We are saying examiner amekupea like this reaction. Amekuambia at the green one ndio ulikuwa umechorewa. That was 1 molar. Then you are told the experiment now was repeated using 0.3 molar. So for 0.3 molar it means a lower concentration. So a slower rate of reaction, which now should be drawn on the right, but it should originate from 0. Lazima ianze 0. So itakuwa slower. Then also the examiner has told you now to draw another one whereby now you are using formula here. Formula means it's the higher concentration, a faster rate of reaction. So it has to be drawn on the left. Umeshika? The student was asking, umeelewa?
There is a student, Dennis Wanjala, whose hand was up.
Okay.
Dennis
Excuse me,
Wanjala.
sir. Excuse me, sir.
Yes.
Yes. My question is, you have said that catalyst lowers the activation energy
Yes.
of reacting particles,
Yeah.
leading to more successful collision, hence faster the rate of reaction. May you elaborate further, please?
Okay, I'll be able to talk about mambo ya catalyst. Nitakupea mpaka analogy, but I can just give you one. Uko nyumbani, uko na kuni ama uko na chako jiko, unataka kuwakisha, unapepeta na ile sahani sijui nini haiwaki. Unafanyanga nini ndio iwake haraka? What do you do?
Weka mafuta.
Yes. Sasa hiyo paraffin unaweka pale, hiyo ndio kama activation energy. It reduces hiyo energy yote, unashinda unapepeta. Unafanya hivi, unapepeta kama maumau na hakuna kitu inawaka. Unarushia tu mafuta taa, 1 minute unaona inawaka. That is exactly how a catalyst works. Unaenda unachukua kuni pale, unawakisha baki. Unakuja tu unamwagia mafuta taa, it reduces which that energy. Imereduce yenye ulikuwa umepepeta, umepepea tu hivi na mdomo, umechukua sahani, alafu tena unachukua tu ukibakia mafuta, unachukua tu kama matchstick, anahakisha kila kitu. That is what it's about. Yes.
Please wind up your time. Your time is.
Yes.
Yes.
We are through and we're just waiting for that. So we are through. We are going to continue from there. Concept of catalyst. So I think now from there we can take Mutiti and the other.
Teacher, where can we find the video?
We'll give you guidance in the group.
Mr. Baluka, I think we'll do it next time because you know it is towards lunch and the glucose level is going down.
Yeah.
Okay, thank you, Ms. Jeff and Baluka and Ruth. It was a wonderful lesson. The next lesson begins at midday, and all the students must rename themselves based on where they are coming from, where they are following the lessons from. Every student must train himself or herself on how to rename. Otherwise, from tomorrow, we will not admit any candidate who will not have renamed himself or herself appropriately. So for the next lesson, we won't keep on singing the same song of rename yourself because it is a must, it is mandatory. You rename yourself starting with the county, your name, your admission number and school. Full name, not initials or acronym. Number 2, if you are joining as a group, you must write the county you are following from. You must write where you are following the lessons from. And you must write the number of candidates that are following that lesson. Otherwise, Consolata, please, you can take off.